Oops. Okay, filming. So you guys should be on day 6, these notes that I have for you, right? I think you're going to like what we're doing today. I hope you are good at recognizing, okay, not very original, but recognizing an alternating series as opposed to a series with negative terms, right? So we can have so you really do have to, like inherent in the name, you have to alternate signs to be an alternating series. So what we're going to do today is we're going to deal with series with negative terms without any kind of pattern. And this is very empowering for us as Calc students, as you guys are Calc students. So we're going to talk, this was an alternating series. Check. You got it, right? You guys were good with that homework? Yeah. Right, good with that classwork? So now we're going to talk about how to test for convergence with series that have negative terms that don't alternate. Okay. So the only test that you've been able to use so far with negative terms is alternating series if they alternate, and then the divergence test, just to see if it diverges. That's it. No, you can't conclude. What?
Oh, I didn't know if you
Just stabbing me so my pen. Yeah.
Should they be a 1-7?
I just made it up. No, I just made it up. Random. But yeah, I love the way you want to look for patterns. Yes, exactly. That would be a good pattern. On the test, you guys have 2 days to review for the test. I love, people have been like, oh, Ms. Jenkins, you told me this was going to be hard. It's not hard. Like a lot of people have been saying this.
Oh, is this?
The test is wicked hard. I'm not going to lie. I was looking at it, I'm like, oh, God, it's so hard.
So is it just like converge or diverge?
It's converge or diverge, but it's also given the first 4 terms of a sequence, of a series. Yeah, and you have to find the pattern. Much harder. So not only do you have 2, 4, 6, 8 tests to use and decide which ones are applicable, but you also will have to determine the pattern. That's harder. I know. So you guys have to be, I know you're my math superstars. You got this. I'll talk about it more. You have 2 review days. You guys know that, right? 2 review days. So now, let's talk about dealing with proving convergence when your terms, when you have negative non-oscillating terms. When you have negative terms that don't alternate.
Learned 6 tests. You just like started memorizing that.
Right. So, here's the cool thing. You guys ready for this? You can use all the tests you've learned, limit comparison, You can do any of these, ratio test, root test. N equals 1 to infinity by proving the absolute value of the general term. You use absolute value of the general term in those tests, and if you can show that the absolute value of the series converges, then the series will converge. That's the concept for today.
As long as it's not alternating.
Doesn't matter.
Oh,
I'm going to prove it, and then we're going to talk about it, and then I'll do some examples. So that's where we're going today. So that means all those tests we can use. So let's go. Let's prove this. So what is this saying? Do you guys see on your thing here it says proof? That's where I want you to be writing right now. I'm skipping all that other stuff. So it says proof. If you're given, or you can prove, or you can show that n equals 1, the absolute value of some general term converges, then must also converge. right. So here's the trick to do this. So the trick is that I'm going to say is equal to the series with a sub n, and I'm going to add an absolute value term and subtract the exact same term but the absolute value, right? So this is like adding 0. So I'm good? Okay, so now I'm going to focus on these first two terms of my expression. So let's think about case 1. What happens if all the terms are positive? Let's just pretend there are no negative terms. All the terms are positive. So what happens with these two things? Well, I get this a sub n plus the absolute value of a sub n. And that's just going to equal 2 of them, right? Because this is all, obviously all positive. And then if these are all positive, I'm going to say I get 2 of those. So what happens case 2 if they're all negative? So I'm going extremes here, aren't I? All terms negative. Yeah, exactly. So for these two, if they're all negative, a sub n plus the positives of them all is going to be 0. Unfortunately, I have to erase because I've run out of board and I have this little board space for this.
Wait, I can't see what you
Sorry. So case 1, all terms are positive, and I get 2 absolute value of a sub n. Case 2, all terms negative, and I get -1 plus 1, -2 plus 2. Right, so I get 0. Now, case 3, which I have to write, I gotta start up here. Case 3, what if I have it mixed? Some negative, some positive, in no particular order. It could be positive, 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 negative. Positive, 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 negative, negative, negative. But let's just say it's mixed. Somewhere between here, don't you believe me that the value of this must be somewhere between this and that?
Yeah.
Right? So like, if you guys all owe me $1, I get $27. Woohoo. But if I owe you $12, I get amount $27, negative $27. And if some of you owe me and some of you don't, I'm halfway in between, but I can never get more than $27, right? That's kind of the theory going here. Right? The idea is that I'm going to be somewhere in between. If you can prove convergence, if you get a finite number and you're subtracting away some values, it's got to converge in your head. It's got to make sense, right? If you get 10, and then somewhere in the line I'm subtracting out a half and a quarter, and it's got to still converge. So now, I have to erase this. Is this okay? Is it okay if I erase?
Yes.
Okay, I'll erase this bottom part. So now let's go back. I actually have to rewrite this thing. Equals. Remember how I did this? Plus, minus that. So what's the max value of that? Well, to figure that out, I'm going to use this. What did I say? If the max value, if these two are positive, I get, you see what I'm doing here? Taking this out
Absolute value of a
of these, which equals, I mean, that makes sense to me. I hope it makes sense to you. If they're all positive, if you add them all up, you get the absolute value. That's the most it can be. Yeah? So what's the minimum? Well, I said that these two can be 0. That's the minimum it's going to be. So I would get 0 minus the absolute value, which is just, yeah, it's just negative. You're adding up all these terms, but you're just multiplying it by -1. So it's negative. And if it's mixed, it's somewhere in between there. That's the premise. If you can prove, I have to erase in a second. I better shut up. Okay, so this is my proof. Yeah, questions?
It's not the other way around, right? If you say the absolute value diverges, you can't
Right.
say that the actual.
Yeah, very good. Yeah, good, Jane. Nice. I knew you came for that. Yeah, we're talking about convergence right now. Ready? Smarty for Smarty, you. Good, Jane. All right, so I have to erase. Is it okay you guys got this down, this proof? Because I think that's so... No. No. Oh, wait, I left it up there so long for me, Xander. All right, so... So if you can prove that that converges, we say that this converges absolutely, like they're absolute value bars. This is a vocabulary term in higher level math. Absolute conversion, you took absolute value. This will also converge, it must. This will converge absolutely. If you take the absolute value and you still get a finite value, right, when you sum up all those terms. It converges absolutely. So think about like, if we have a geometric,
Is that as opposed to absolute convergence?
same, converges absolutely, absolute convergence.
Oh,
So you can say it converges absolutely as the adverb, or you can say absolute convergence.
so is that also the same as
Adjective?
converges?
Yeah, no, it's not.
What?
Is that absolutely referring to the absolute value?
So let me explain, yeah. No, let me explain.
Like, pause
So
it,
this,
like, definitely.
totally, so absolutely. So, does this converge?
Yeah.
It has negative terms, right?
Yeah.
But it still converges. If I took the absolute value of this, does it still converge?
No.
Converges absolutely.
And it also converges.
Oh,
Yeah,
so that's
so it
okay.
converges absolutely. If I take the absolute value of the a sub n term and it still converges, it converges out. It doesn't matter if I'm subtracting terms.
So is this the whole like a square can be a rectangle, but a rectangle can be
Yeah, I kind of like that, right?
bigger one.
Yeah. So now, what about this one, n equals 1? What about negative 1 to the n of 1 over n? Does that converge?
Yes.
What happens if I take the absolute value of this? Does that converge?
No.
This does not converge absolutely. It converges conditionally. This is conditional convergence.
Which is normal convergence.
Yeah. Convergence.
But
It's conditional on the negative terms, folks. That's what that means. Conditional on the fact that you're subtracting out some values. You're pulling it in, you're reining it in. It's conditional on the negativity of some of the terms. If it weren't for those negative terms, I would diverge. But I add and then I subtract. I add and then I subtract, and I'm reining in my sum. I'm reining it in, pulling it back, making it smaller, making it a finite number. I hope that makes sense.
Like, what does that tell you?
Wait, say that again?
Because
Okay, let me, so, wait, what was your question?
it does converge.
It was just a go to say it again.
You might have to go to the video. I don't know, I forget what I just said.
No problem.
If I take away these absolute value bars, I'm good.
Yeah.
It converges. If I throw them in there and I make it just the regular old harmonic series, I diverge. So the idea is, it's contingent upon some of the terms being negative, because I'm adding and then I'm subtracting. I'm adding and then I'm subtracting. And I'm adding it, and that makes my number a little smaller, small enough that I can get a finite number. All right, that's the concept, and I'm sweating, yeah, I'm sweating. So now let me do some examples, and then I think you guys will be good. I know,
So is it just
I'm earning my pay up here.
Inclusive if it doesn't.
Let me show you. I think I have to keep going. I mean, these are questions, but okay. Ready?
Yeah.
So,
You leave the last one.
oh, sorry, I didn't hear this one too late. It wasn't intentional. Looks like you're watching the video.
I was sad.
Watching the video and pausing. Right. So, all right. So go to the back, and you have an example there.
No matter what.
I don't know why it says example 3. Have I done 2 examples? No. I skipped those. No! Whoops. I made my E like a sigma. Example 3. I'm sorry guys, please include the n equals 1 to infinity. Okay. All right, so I don't know if you guys get this. We always want to prove convergence. If we have an infinite series that diverges, we can't do very much with it, right? Like it's kind of cool, like the harmonic, but we want to be able to sum these things up or get an approximation, so we want to prove convergence. There are now 2 ways to do this. The first one I'm going to do is prove absolute convergence. If you can prove absolute convergence, then this must converge as well. So we're going to, so method 1, I think we're just, doesn't it say method 1 on your notes?
Yeah.
Yeah, okay. So, method 1, prove that this series converges absolutely. If it converges absolutely, if we have negative terms in there, it's going to converge even more. Right? If we throw in, okay, that's not really right? It just converges. So, okay, Colin, good. Yeah, good call. So, he's like, Ms. Jenkins, this converges. I know, I can read you after 2 years of video. No? All right, so let's prove that it converges absolutely. So this is what we're going to do. I told you, let's just pretend we ignore that. We're going to take the absolute value. You do not know any test that will work with that in there. Right?
Wait, so if you,
So we're going to take the absolute value,
Well, we know the alternating.
take absolute value. So we're going to throw away, so basically get rid of that negative 1 to the n. That's what we're going to do. We're going to disregard it. Let's see what happens. N over n cubed plus 1. So we're taking the absolute value of this. I mean, that's really unmathy. I'm embarrassed. We know college professors see this. So I just take the absolute value of this whole thing, right? Which is this. That negative 1, 1, negative 1, no longer an issue. So now I hope you guys recognize what should we use to prove convergence here?
Comparison.
Love limit comparison test. I love it. You were the one I heard the most. Star Wars Superstar. Sorry.
yes.
Sorry, Magenta Swan. Sorry, come on. So I would say limit comparison. Sure.
Yeah, I
It's
feel
easy
like you
with
can
this.
always use both, right?
Yeah, it's easier to do limit comparison though, because as n gets very large,
Use both that and what else?
what does this start to look like? So that's what we're going to compare it to.
Over n squared.
So compare this to our b sub n, which is this. So how do we do limit comparison test, guys?
The limit
Let-
of
I know,
1
I'd like to do
over
this. Let-
a-
E equals.
Roll. That's a terrible roll. Equal
the limit
the limit.
n goes to infinity
Of-
of a of n over
Yes, good.
d of n.
Oh.
Okay.
Yeah, it can be anything, which is equal to the limit as n goes to infinity of that n over plus 1 divided by b sub n. I'm going to multiply by the reciprocal, n squared over 1, which equals 1. And because rho is a finite number, you just proved not just convergence, you proved absolute convergence. And you might want to say, since rho is a finite non-zero number, you guys are good at that, right? Zero is inconclusive
Oh, so
here.
that always proves absolute convergence?
Yeah.
We didn't learn
Since
that when we
rho is a finite non-zero value, this converges absolutely. Because it's the max it can be. This is the max value it can be if I don't subtract anything. I'm just adding, and it still converges. If I add, subtract, it'll converge to even smaller. Yeah? So now the doors are open, and you have to now officially start using all the tests you've known.
Wait, is method 2 using the A?
Yeah, so this is actually an alternating series. So you can use alternating series test as well. Is it okay if I don't do that?
Yes.
All right, so that's all there is for the notes, guys. I'm going to give you, that gives you 15 minutes in class. Let me turn this off. 20 minutes.